how to do this exercise over here in Matlab using the Jordan. Now, I haven't yet explored the situation in which you get multiplicity for the eigenvalues and you get a complex values for the eigenvalues using the Jordan. So right now, I know that this is going to give me distinct eigenvalues. So I just want to show you how to put it in Matlab and do this problem really fast. What it's asking is for us to solve this system of linear first order differential equations. And we're going to first put it into matrix form, as I did right here. And if you go ahead and multiply these out, you're going to find out that you'll get this right-hand side. And then we're going to define this A matrix, which is this coefficient matrix in Matlab, and we're going to ask it to take the Jordan of it. So let's go to Matlab. And the first thing you always want to do is you want to define some variables. Now in this case, I don't want to define anything. I don't need to clear anything because my workspace is clear. So we can simply define the coefficient matrix of our system. And the coefficient matrix of our system. So to define a matrix, you put the equal sign. You can use any symbol you want. The equal sign just assigns a value to those symbols, and the square brackets make Matlab know that this is going to be a matrix. So it's going to be 1, the first row is going to be 1, 1, negative 1. To go to the next row, you put a semicolon, and then 0, 2, 0 for the second row, and the third row is 0, 1, negative 1. Then I put a semicolon here because I don't want it to output in the workspace here. And now I'm just going to use the Jordan function to find the eigenvectors and the eigenvalues, corresponding eigenvalues. So how it works is this. You need to give it an output, and it's going to output two different things. It's going to output vectors first. So I would say I would call the first outputting thing vectors, and the second is going to be the values. So I put a square brackets because this output is also a matrix output because it's outputting more than one thing. And now on this side, I'm just going to write Jordan, and I'm going to apply the Jordan to A. Now I'm not going to put a semicolon because I want it to output the result. So I'm just going to press Control Enter. Matlab is thinking, and here we're going to get our solutions. So we get a vector 1, 0, 0 associated with this value. Then we get a vector 2, 3, 1 associated with this eigenvalue, and a vector 0.5, 0, and 1 associated with this eigenvalue. And with this, we can use the superposition principles to add them up together by multiplying by 3 distinct constants, and we get a general solution for this system right here. I hope this was helpful, and I'll see you next time, probably for something other than distinct eigenvalues.